Hello, and welcome to today's lesson on the reactions of metals with water and acids. In this lesson, we will explain the products of reactions between metals and water or dilute acid. Then we will learn about the relationship between metal reactivity and the release of hydrogen gas. So far, you have become familiar with the reactivity series, which ranks metals from most to least reactive. You also have an understanding of the general reactions between metals and oxygen. We will expand on this foundation and explore more reactions in this lesson. Let's dive into the main concept of today's lesson: the reactions of metals with water and dilute acids, starting with water. When a metal reacts with water, it typically forms a metal hydroxide and releases hydrogen gas. The general equation for this reaction can be represented as follows. Metal plus water produces metal hydroxide plus hydrogen gas. For example, let's consider the reaction of potassium, K, with water. 2K plus 2H2O produces 2KOH plus H2. In this reaction, potassium reacts vigorously with water to form potassium hydroxide, KOH, and hydrogen gas, H2. The intensity of the reaction is linked to the position of potassium in the reactivity series, as potassium is a highly reactive metal. A less reactive metal would not react as vigorously. One particular reaction to note is that of calcium with water. K plus 2, H2O produces Ca, OH2 plus H2. When this reaction is performed, one can observe that the water turns milky. This is due to calcium hydroxide being only slightly soluble in water, meaning that some of it remains as solid in the solution, giving it its milky color. This table summarizes the observations for some metals in decreasing order of reactivity. It reflects the significance of the reactivity series in the behavior of metals in their reactions. Similarly, when a metal reacts with a dilute acid, it forms a salt and releases hydrogen gas. The general equation for this reaction is metal plus dilute acid produces salt plus hydrogen gas. For instance, let's look at the reaction between magnesium, Mg, and dilute sulfuric acid, H2SO4. Mg plus H2, SO4 produces Mg, SO4 plus H2. In this reaction, magnesium reacts with sulfuric acid to form magnesium sulfate, MgSO4, and hydrogen gas, H2. The reactivity of magnesium allows it to displace hydrogen from the acid. The reactivity of the metal reacting determines how violent and vigorous the reaction with the acid will be. Metals that are very unreactive, specifically below hydrogen in the reactivity series, such as gold or platinum, will not react at all. The observations can be used to qualitatively gain an idea of a metal's reactivity. Whether a metal will react with water or a dilute acid depends on its reactivity compared to hydrogen. In the reactivity series, metals that are more reactive than hydrogen will displace hydrogen from water or acids, resulting in the formation of metal hydroxides, or salts, and the release of hydrogen gas. Conversely, metals that are less reactive than hydrogen will not react with water or dilute acids. This is crucial for several reasons. There are safety considerations, so knowing the reactivity of metals helps prevent accidents. For example, highly reactive metals like potassium can explode upon contact with water. There are also practical applications, so understanding metal reactivity aids in selecting the right materials for various purposes. For instance, gold is chosen for jewelry because it does not react with water or dilute acids, preventing corrosion. By remembering these key points, you will be able to predict the products of reactions between metals and water or dilute acids. This deeper understanding not only enhances your knowledge of chemical reactions, but also highlights the practical importance of metal reactivity in everyday scenarios. In today's lesson, we delved into the reactions between metals and water or dilute acids, focusing on how these reactions produce hydrogen gas and how the reactivity of metals influences these reactions. We started by understanding that metals reacting with water typically form metal hydroxides and hydrogen gas, demonstrated using the example of potassium reacting with water. Similarly, when metals react with dilute acids, they form salts and hydrogen gas, as shown by the reaction between magnesium and sulfuric acid. We emphasized the importance of the reactivity series, explaining that metals more reactive than hydrogen will easily displace hydrogen from water or acids, resulting in the formation of respective compounds and the release of hydrogen gas. Metals less reactive than hydrogen do not react with water or dilute acids. This knowledge is crucial for safety considerations, such as preventing accidents with highly reactive metals, and for practical applications, such as selecting materials that resist corrosion.